Okay, so we started recording. Oh, go ahead. You can start.
Hi, I'm Milo. I'm a freshman mechanical engineer at Rose-Hulman.
Hi, I'm Jack Behringer. I'm also a mechanical engineer, but I am a sophomore.
Hi, I'm Aiden Posey, and I'm a freshman mechanical engineer.
Today we're going to show you our game. Our game is based off the Atari style asteroids. We swapped out the asteroids for box fans. We also added power-ups to ours. There's a V-shot, a missile, and then an ammo addition. Along with that, in the original asteroids, there's not an ammo count. We decided to add an ammo count for our game to add a little bit more challenge since we were giving people an edge up with the power-ups. Next we're gonna pull up our game and we're gonna play a round of that along with explaining some of the stuff.
Oh, that's not gonna work. Well, opens in a new window. Not
Share
gonna
the
work.
screen.
It is sharing.
It's not gonna work.
Okay.
See, it's not working
Why is it not working?
because
You
you
open
did the
new
thing I
window.
said wouldn't work. Stop sharing.
We can cut this out, don't worry.
No, we won't. We're one
What?
taking it.
Oh, okay.
Share. Screen.
Okay.
Yeah. So now just restart.
We're gonna restart the
Yeah.
game here. Like
So this is our project that we made. The character can both turn left and right as well as accelerate forwards. One challenge that we had doing this was having the character have inertia, which means that when it's traveling forward, it slowly comes to a stop, even when you're trying to turn. So it feels a little more realistic, like you're flying around in space. Um, the character can pick up one of three power-ups. The V shot, like Jack picked up earlier, shoots two bullets at once in a V pattern. There's a missile power-up, which we might see later, which shoots a missile, which has a large explosion, and can take out the box fans. And then there's a bullets power up, which just adds more ammo to the ammo count. The ship also can collide with the box fans, and when it does, it triggers a death animation where the character blinks a couple of times and then it respawns. And when it respawns, it has a couple seconds of invincibility so that it doesn't get hit by the asteroid right away. We also incorporated several levels into this where every time you destroy all of the asteroids, it'll respawn new ones.
Now we're just gonna play the game until we find more of our power-ups. The power-ups are distributed at random whenever the asteroids shatter from being hit or being destroyed. So it's really a random guess to what power-up you're gonna get, or if you even get a power-up that explosion. Seems like right now our luck has been pretty bad. We did get one there, but it's a very low chance that you get a power up just because we feel as though it adds a little bit too much to the game if you were constantly getting power ups. And then at the end, once you're done, you can see that there's a respawn page and your score posted above. Now we're gonna go take a deeper dive into the code, starting with what Milo did working with the box fans.
You want to just pass off with
Yeah, sure.
So I worked on both the box fans and the box fan classes. In these classes, there are a number of methods such as um, the add box fan, the draw, the shatter, the movement, which I also put in calls for the other ones so I didn't have to call in game again. There's a power-up spawner that has a 1 in 5 chance to spawn a power-up whenever you destroy an asteroid. There's also the respawn, the explode box, and a number of other things in the box fan singular class. In this class, we have move, draw, off screen, which allows the box fans to move off screen and sort of spawn in back on the other side. There's the check hit for the bullet, the check hit for the ship, the check hit for the missile, and the check hit of explosion of a missile.
Next, we're going to talk about the shootables and missiles objects, which I ended up working on. So if we go to our shootables file here, as you can see, it is a rather hefty file. You go ahead and go. So in this file, we have the draw, so it draws all the bullets, the missiles, the explosions. It also moves all the bullets and missiles. We had the explosion stay in spot. We also have add bullet, add missile, add explosion. We also have remove bullet, remove missile, remove explosion. Um, in each of these, there'll be sounds that fire, along with certain removal processes. Um, and then we also have our fire system. So that allows us to fire and it sends off a shot of either the missile, the V shot, the regular shot, depending on what power-ups we have picked up. We also needed our X and Y to be used in um, the table, along with we needed to be able to get power-ups. Then this here, this is the explosions file. I use this just to generate an object. So it only has the draw function. It's a really small file, but it's used so that the explosion is an object and it's a lot easier to manipulate it. Over here, this is the bullets file. This one has the draw, the move, and then also a get X, so I can get the X and Y positions. And then let me find missile here. Sorry. Okay. So now in the missile file, we have our draw, we have our move. We also have another get X and get Y. In the move, we have just our speeds and our different angles. I think that should be it for me. Yes. We're also going to return back to Milo. He had a little bit more to add to his.
All right. So for a lot of my methods, I'm going to explain some of them. So the move is a simple move. The draw allows all of the images of box fans to be blitted to the screen. The reason why we chose box fan and box fans is because in box fans, we have this list where we add to that list. This list kind of runs half the game. It allows us to call the levels. So we see when that list is empty, and then we call the next level to spawn in a bunch of other box fans using the add box fan function. The shatter is actually an interesting one because we have to measure the size that it is, and based off of that, either spawn two more in a random direction, or we completely erase that box fan. The thing so interesting about this is we had some issues with the box fan size going below 0, and when that happened, it wouldn't be taken away. Because if you hit it twice at the same time with a bullet, it would crash the game because this little thing, the boxfan.alive, was not implemented yet. That allowed us to have a sort of check to see if the box fan is already dead before we try to remove it again. And I have to give credit to my two other teammates. A lot of the implementation between the two, the box fans and the ship, or the box fans and the bullets, was actually figured out and heavily aided by them.
We're going to now pass it to Aiden. He's going to talk about his ship category.
So the main piece of code that I wrote was this ship function. It has a lot of different variables inside of it because it needs to keep track of its position, its speed, and its acceleration, as well as the angle to which it's facing. I'll start off with the move function. The main thing that you can do is turn left and right as well as go forward. So our turn function is right here. It's actually split up into two different functions. The turn function basically just changes the angle that is referenced everywhere else throughout the game by the set amount when you're pressing the left or the right button. Then the rotate function transforms the image of our ship to angle it to this specific angle so that the ship appears like it's looking at the correct angle. Then, instead of the move function like most other objects have, we have an accelerate function, which is when you press forwards, it will accelerate by a set amount in the specific direction that you're facing with the angle, using the math and cosine, the sines and cosines of the angles from the math function. Then we need to draw this function. Inside the draw function is where we handle all of the movement of everything. Since the accelerate function changes the speed of the object, that means it'll speed up or slow down instead of moving at a consistent speed. So the first thing we do in the draw function is there's a little decay section where it'll slowly slow down over time. So you'll come to a stop instead of drifting off forever across the screen. And then the next part of this is just moving your position, and it also checks to see if the character is invincible, because when you die, we don't want the character to be able to move right away when we're playing that die animation. And this is the code that handles that animation. We have a little time variable that ticks each time the clock is ran, and then that number corresponds to it'll become 1 every second, and then just this is the code that handles the animation. Then another big class that I worked on was the display file, which has a lot of different functions in it, but it mainly handles the text in the top left corner of the screen. Um, and then it has a lot of different functions down here for the several different classes to be able to call these functions so that all of the classes interact properly with our display. And then finally, I worked on the power up and power ups function. The power up function mainly just holds all of the different images and the types of power ups that it can be, as well as it has a collider where it can check. And then the power ups function checks the colliders again for every item in that list. And then it checks which type of power up it is. And then it does the corresponding action with the display or with the ship fire function that it should.
Okay, and then to wrap things up, we have assessed all of what we were able to do in our original idea that we wanted to implement. We decided that our essentials were we want move, we want to be able to move, we want to have asteroids, we want to have a ship, we want to have collisions happening, and we want to have a score. We feel as though we have met all those essentials, and then we also feel that we have met all of our extras of having power-ups, having inertia, sound, a scoreboard, levels, and an ammo count. So this is why we feel we deserve an A in this project, because we feel like we have met all of our essentials and extras.
As well as we made sure that our game that we picked was able to challenge our skills so that we would be able to learn and develop new skills throughout programming this project, and we didn't make it too easy for ourselves.
Okay. Thank you. We had a great year this year, and yeah, bye.
Sharing, and then you have to stop. Cool.
Yeah.